Okay, we're going to look at this polynomial. It's a third degree polynomial. How do I know that? Because the largest exponent is 3. And that tells me the end behavior, and so does the lead coefficient. The lead coefficient is 2, positive 2, and it is the lead coefficient because it's with the highest exponent. So the fact that my lead coefficient, which is 2, is positive, and the fact that my degree is an odd number, then I know my end behavior is this. Okay, that 4-square chart you have in your notes, you want to check that. And that's something you have to memorize. So I know that I'm going to plot some points, but at the very end, this is how my graph is going to look like. Now I have to find the zeros, and I will tell you that there are only real zeros here. And I can't factor this. I can't use quadratic formula because it's to the third degree and not the second degree. So I'm going to try some different roots using division, and if I get a remainder of 0, then I know that that number I tried is a root or a 0, that it's a 0. So I have to start guessing which zeros will work. The first thing is I'm going to add all the coefficients and see if they add up to 1. 2 plus 3 is 5, and 5 minus 13 is negative 13, and negative 13 plus 8, of course, is not 1. I'm sorry, is not 0. So I'm going to find the rational zero test, where I take the factors of the constant, and p is the constant. Here it's 8, over the factors of the lead coefficient. Here it's q. So let's see, the factors of 8, all factors positive and negative. So positive and plus or minus 1, plus or minus 2, plus or minus 4, and of course plus or minus 8. All right, now the denominator. That's easy. Plus or minus 1, plus or minus 2, because 2 is prime. And so now you list all the possible factors without writing duplicates. So you're going to go, let me get a highlighter so you can guys see how I'm doing this. You're going to go 1 over 1 is just 1. So let's see, so 1. And then 1 over 2. And that's, so plus or minus 1, plus or minus 1/2. And now I'm going to do the same thing with 2. So 2 over 1 is 2, and 2 over 2 is 1. I already have 1. And 4 over 1 is 4. And 4 over 2 is 2. I already have 2. And 8 over 1 is 8. And 8 over 2 is 4, and I already have 4. So my zeros are going to come from here. And since this is to the third degree, I should have 3 zeros. Now I might have just 2, and one of them has a multiplicity of 2, giving me my cubic function. So let's take a look. 1 doesn't work. Negative 1. Let's see if negative 1 works. And negative 1, you know what? We can just, instead of using synthetic division, I can just evaluate the function of negative 1 and see if I get 0. So negative 1 cubed is negative 1. So negative 2 plus 3, that's 1. And in order for this to be 0, these two have to equal negative 1, and that's not going to work. So 1 and negative 1, they are not 0. So I'm going to cross that out. Okay, you know what? Let's try 1/2. Let's try 1/2. So I'm going to, let's see here. Is 1/2 a 0? And I'm going to, let's see, 2, 3, negative 18, and 8. And as you can see, I don't need any placeholders. Okay, so 2 times 1/2 is 1. 3 plus 1 is 4. 4 times 1/2 is 2. And this is going to give me negative 16. Negative 16 and 1/2 is negative 8. And 8 minus 8, 0. So 1/2 is a 0. And when we see factors, we generally don't write, you don't see x minus 1/2 as a factor, so we're going to talk about how you fix that in a minute. But yes, for now we know that x minus 1/2 is a 0. Okay, so let's try another one. Let me just kind of erase this. Let's try negative 1/2. So 2 times negative 1/2 is negative 1. 3 minus 1 is 2. 2 times negative 1/2 is 1 again, is negative 1 again. This is going to give me negative 19. And negative 9, half of negative 19 is going to give me a remainder, so that didn't work. Okay. Let's try our hand at positive 2. All right, so we're done with the 1/2. And you don't have to go in order. I'm just going in order. I'm going to try positive 2. All right. 2 times 2 is 4. This gives me 7. And this gives me 14. And this gives me -4, -8. Look at that. It worked. So 2 is a 0. So x minus 2 is a factor. Okay. And you know what, too? If 2 works, odds are -2 is not going to work. But let's see. Let me erase. I'm going to bring down the 2. 2 times -2 is -4. -1, positive 2, -16, and -16 and 2 is positive 32, so that's going to give me a remainder. That didn't work. Okay, so we had 2 positive zeros for this one, and we tried all the 2's. All right, for this, I'm going to try -4 first. We have 2 positive zeros, so let's try a -0. So let's see here. 2, 3, -18, 8. Bring down the 2. 2 goes in. 2 times -4 is -8. 3 minus 8 is -5. -5, so that's going to be positive 20. Positive 2. 2 times -4 is -8. And look at that. There we go. And there is my last root, x plus 4. So we now have the roots of my polynomial. So let me erase this. And now we're going to find the x-intercept. We found the x-intercepts. Let's find the y-intercept. Let's consider the multiplicity. And let's graph it and see if we need any additional points. So let me erase all of this. Okay, so I'm going to go over here. And by the way, I had said that we generally don't see x minus 1/2 as a 0. So we don't see factors that have fractions in them. So I want to preserve the equality. I want to make sure it's the same value, but I want to get rid of the fraction. What can I multiply 1/2 by so it's no longer a fraction? 2, you're right. So if I multiply this by 2, 2 times x, that's 2x. And 2 times -1/2, that's -1. So notice if I set this equal to 0, I get x equals 1/2, which is what I would get down here, except now it's something that you would see if you factored. So times x minus 2. And if you're asking, do we have to do this for periods 3, 4, and 6, I showed all of you how to do it. So yes, you have to do it for the test. X minus 2 and x plus 4. Equals 0. So those are my x-intercepts are x equals positive 1/2, x equals 2, x equals -4. Okay. Next, my y-intercept. And my y-intercept is when x is 0. So that's going to be 2 times 0 minus 1 times 0 minus 2 times 0 plus 4. And what's that going to give me? Let's see, -1 times -2, that's positive 2, and positive 2 times 4, that's 8. So that's my y-intercept. Okay, so 0, 8 is that point. Okay, let's go ahead and graph this. So I'm just going to erase to give me more room. And let's see if I can get different paper here. Let's see. Yes, we want graph paper. Okay. Come on. Okay. So let me Okay. So I'm going to go ahead and draw my axes. Black. All right, here we go. So okay. And okay. So I have a 0 at positive 1/2. So let's see. I'm going to say that's 1, and that's 2, and that's 3, and I'm going to say 1, and that's 4, and that's negative 1 and negative 2. Whoops, I think I'm going to run out of room. Negative 3. Oh, I barely made it. Negative 4. Okay. And let's see. 1, 2, 3, 4, 5, 6, 7, 8. All right. So let's see. Let's remember what our polynomial was. It was y equals 2x minus 1, x minus 2, and x plus 4. So my this 0 is positive 1/2. So let's use a different color. So positive 1/2. There we go. It's right there. And x minus 2. So this 0 is positive 2 right there. And this 0 is x is negative 4. So that's over here. And my y-intercept is here. And notice the multiplicity for these three. So the multiplicity, this is a multiplicity of 1, this is a multiplicity of 1, and this is a multiplicity of 1. Therefore, all three of these zeros cross the x-axis. So I have to cross the x-axis, but I have to make sure to touch the y-intercept too. And remember, my end behavior was this, because it was odd degree and positive coefficient. So let me just get a different color here. Okay, so I'm going to start here. It's going to cross. It's going to cross again. Remember, I got to touch this, and then it's got to go down like that. And not the prettiest function, but there's your cubic function. Now, actually just fix that. That's terrible. Yeah, I'm going to do that again. All right, guys. So let's see. Okay. So now you want to ask, are there any additional points required? Well, right here, I wonder how low that goes. I just kind of guessed when I looped over. But let's evaluate this function at a point to see. And luckily, I can evaluate this function at 1. So when I plug in positive 1, let's see what I get, because 1 isn't a 0. So you want to pick points that are not already x-intercepts. Otherwise, you're going to end up with 0, right? So, and that's going to be, it's useless to you. So let's see, if I plug in 1, let me just kind of erase some of this junk here. Okay. If I plug in 1, if I, 2 times 1 minus 1, so 2 minus 1 is 1. 1 minus 2 is negative 1, and 1 plus 4 is 5. So negative 5 is a point, because 1 times negative 1 times 5 is a point. So negative 5 is a point. So, oh, what happened to my axis? We're going to have to go ahead and find where negative 5 is. So let's see. Negative 1, negative 2, negative 3, negative 4, negative, here's negative 5. So at positive 1, it's negative 5. So I actually, do you see how I have to go lower? So thankfully, whoops. Well, actually, I'm going to go ahead. That's okay. And I'm going to go ahead and say 1, negative 5 is a point. So right there. And let's see what my graph looks like now. So it's going to start here. Remember, it's going to go through all these points in a fluid, curvy motion, because polynomials don't have jagged edges. I cross here, I touch this point here because that's as low as it goes here, I'm going to cross back up. I'm going to touch my y-intercept, and down here it crosses as well. And there's my function. So that is a good example of what you'll see on the test. Okay.